Hey. Hello, my math jungle friends. Yes, how are you today? I hope you're doing well. I know you couldn't really answer my question. Anyway, hey, Guillermo. How you? Oh, yeah, I remember you said you needed to talk. Something pretty serious? Oh, my goodness, you're kidding. Oh, that's just wrong. Well, hey, let me tell you something, Guillermo. If there's one thing we try to do in Mr. War's math videos is we always try to, create a happy ending. So we are going to do everything we can to see if we can find your wife and your daughter. Yes. Okay. Hey, that's right. We just had to be hopeful. Okay, things will be okay. All right. Now, if you don't mind, I'm going to shrink you down to size here a little bit. Yeah, because we need to start our math video. But there you go. How about that? Whoa, you man, you're one big dude. Well, hey, welcome, my friends. This is, of course, the last video of Chapter 6 review for the test. So, let's get started. Alana bought 3/8 pound of Swiss cheese and 1/4 pound of American cheese. Which pairs of fractions are equivalent to the amount Alana bought? Mark all that apply. Okay, this is so easy. I mean, these are the finding the equivalent fractions. And so I'm going to go ahead and get my pen. So I think the way I would attack this problem, since they've already given us choices for equivalent fractions, I think I would just line those up side by side. Now, assuming that these are listed respectively, so we have 24/64 does apply to the 3/8, and then the 8/64 refers to the 1/4. I'm assuming that's what. And then if that's the case, which I'm sure that it is, I'm going to go ahead and put my fractions here this way. Okay, and I'm going to go ahead and take my 1/4 then, and then I'm going to put my 8/64 over here. So all I've done is I've listed the fraction and then the equivalent fraction that they claim. Now, do they match up? Well, what would we have to multiply 3 to get to 24? Well, that would be 8. How about here? If I multiply that by 8, 64. Yes, 24/64 is an equivalent fraction for 3/8. Now we come over to the other one. I'd have to multiply an 8 here to get the 8. Now when I multiply this by 8, however, we run into problems. We only get 32. I'm going to continue on with B now and do the exact same thing. I'm going to put my 3/8 with my 6/16 and then my 1/4 with 4/16. And what would I have to multiply 3 to get to a 6? Be 2. Is 8 times 2 16? It is. So this fraction, they're equivalent fractions. I don't have a 2, but rather a 4 because 1 times 4 is 4. And now I have 4 times 4 and it's 4 times 4 16. Indeed it is. And the fact that that 2 is an equivalent fraction, it makes this one here correct. I will mark this one in here and fill that circle up. Yes. Now I think I'm going to have to move Guillermo. Guillermo, sorry, I'm going to have to move you. Okay, now I come to C. Again, I'm going to put my 3/8 next to here. In this case, I have 12 30-seconds. I think I'm going to write the other ones over here. 1/4. And then I have 6 30-seconds over here. Well, 3 times 4 is 12. And of course, 8 times 4 is 32. That fraction works. 1 times I would have to be 6 is 6. However, 4 times 6 is not 32. Sorry, C, you do not get to be part of this elite group. And now I move to D. Again, 3/8. And now I have 1/4 and my 10/40. Here, of course, I'd have to multiply by 5, and then I have to do, and think of that as fifths. We're really multiplying by fifths for both. But what we do to the numerator, they say you must do to the denominator. It must be fair. And so we have 15/40. That works out. Here we have 10, and then if we multiply that by 10, that works up. D. Correct answers are B and D. 4 students spent time volunteering last weekend. The table shows how much time each student spent volunteering. Okay, by looking at the table, we have our title. We have one column with the students listed, the time in hours. Okay, first thing I can tell right away, look at Beth, 6.5 hours. She volunteered the most, and it looks like Amy here, she volunteered the least amount of time. Now it says, match each pair of students with the difference between how much time they spend volunteering. So I'm going to be matching, but with the difference of how much time they spend. Well, when I think of the word difference, I have to think of the word subtract. Okay, when we're finding the difference of something, we are subtracting. So let's go ahead and take Amy and Victor. So Amy and Victor volunteered a little bit more. So I'm going to list his first. He has 5 3/4. We're finding the difference, so we're going to subtract Amy as ours, which was 4 5/6. Now we've done this before, but what I'm going to do today is I'm really going to make sure that you have the algorithm. This is important, your basic skill. Now when you look at these two numbers, you may see right away that 4 and 6 have a common denominator. In fact, what we call the least common denominator is 12. What that means is if we were to find multiples of those two numbers, the first number they would have in common that they would both have would be 12. But I want you to understand that sometimes those denominators are going to get larger. And it's not going to be so easy always to see them. But if you get in the habit of just kind of listing your multiples, this is going to make a big difference. This one's rather easy because when we find the common multiples here, we find 1 of 12. But I want you to know that's not the only one there is. See, if we keep going, you'll see that we're going to get to 24. And ultimately here, we're also going to get to 24. I ran out of room on my paper. But we would get to 24, and that's also a common denominator, or what we call a common multiple, which we will use as a denominator. So I'm going to put 12 down here, and all I'm going to do is, well, 4 times 3, we're going to multiply here by thirds, because 4 times 3 is 12. That's what we needed to do. 4 times 1 times 2 and then times 3. 3 times 3 is 9. And then here we have times 2, right? So that's the top's going to be 2. And later in the video, I will do these faster. However, so that's 10. All right. Now, this is great, except we have a big problem here. Well, we can subtract our whole numbers, 5 minus 4. We can subtract and get 1. Problem is, we can't do 9 minus 10. That's a big problem. So what I'm going to need here to do in this situation then is I'm going to need to regroup, what we call renaming. And in this case, we're going to rename. We're going to rename one of these holes here so that I can add that onto my fraction. It helps us add the fraction because a whole number and a fraction can't be added together. One's a whole number. It's a different type of number, and a fraction, of course, we know isn't quite a whole. But if I were to take one whole away from this, what I could do is I could represent that whole as 12 over 12. So now I still have my 5 because I have my 4 plus another whole, but I'm going to add because I still have that 9/12 there as well. And now I have this new problem. I'm going to rewrite it again, and I'm going to write it as, now I'm going to write 4, but now 12 plus 9, well, that's 21. Now we have 21 over 12 minus 4 and 10/12. Now we can do this problem. Look at the whole number part here, okay, turned to 0. So we're not going to have any more whole part. 21 minus 10 is 11. And now we have 11 over 12. We do have 11 over 12 hour. I see it listed there. So let's go ahead and match that. Cal volunteered for 5 2/3 and Beth for 6 1/2. So 6 1/2 is the larger number. So I'm going to take 6 1/2. I'm going to subtract Cal's 5 2/3. I recognize that as 6. So now I have my common denominator of 6. I'm going to multiply times 3 times 3. 1/2 is equal to 3/6 times 2, and then times 2, that's 4. Okay. And now I can go ahead and, I'm in the same situation. Look at it. I have to rename because my 6 minus 5. So I'm going to go ahead and do that. So I've shown that just like on the previous problem. Same situation. I have the whole parts are going to cancel out here. 5 minus 5 is 0. But here I have 9 6 minus 4 6. So I'm going to take 9 minus 4, which is 5. And then I have my 6. Do I have 5 6 hour? I do. Let's go and connect that line. Now I know what you're thinking. Oh my goodness, there's only one left, so I'm just going to connect the line. I'm going to give you some advice here. You could just draw the line from Beth and Victor to the 3/4 hour. But what if I made a mistake? What if by chance I just made a simple computation error? I'm going to go ahead and do this last one. Beth is 6 1/2 and Victor is 5 3/4. That's so close. I know I could probably do this in my head. But I'm going to follow our process here. Common denominator. Fit that in there. Oh, that's 4 times, so that's not even going to change. I have the same problem here. I cannot take 2 and subtract 3. I can't take 3 from 2. Can't be done. So I'm going to go ahead and cancel that out. You see the 5's cancel again. I end up with 6 over 4 minus 3 over 4, leaving me with 3/4. And sure enough, that is the last answer. Woohoo! Yeah, yeah. Now I feel more confident. That last line in there, there we go. Hey, purple dot, where did you come from? Get out of there. Okay, now it is time to continue. Yeah. This is for numbers 14a through 14d. Tell which expressions require you to rename mixed numbers before you can subtract. Note the word rename. Find each difference. Okay, so they want us to solve it too. Write each expression and the difference in the correct box. We have a little bit of work here. Okay, take the very first one, the key of whether it requires renaming or not. Now, by looking at it, we can't do anything with any of these problems because if you notice, they all have unlike denominators. 14a has 3 and 4, 14b 4 and 8. You can see that they all have different denominators. So we need to find some common denominators. So I guess I'm going to do the work right here in this area. So let's rename them now. So the actual denominators here. So we have a 3 and a 4. I see a common denominator of 12. So I'm going to put 2 and then I'm going to put a 12 and I'm going to subtract 1. Now what do I have to do to 3 to get to 12? I'm multiplying by 4, so by fourths. So 1 times 4 at the top equals 4. Is 4 twelfths a third? 4, 8, 12. Yes, it's 1/3. Now I come multiply by thirds. I end up with the 12 here. 4 times 3. Now times 3, get 9 twelfths. Looking at that, you can see that yes, this one does require renaming. It's going to go in this left box. But it also says that we need to find each difference. Okay, so now let's go ahead and let's do our renaming. That's going to leave 1 there. I end up with 12 over 12. Now I'm going to subtract my 1 and 9 twelfths. Now you can see here I have 12 plus 4, which is 16 over 12 minus, and in this case, oh, I didn't put my 1 here, but you can see our 1s are going to cancel out. So we end up with 9 over 12, which is going to equal 7 twelfths. Okay, 1 down, next one to go. We have 1 and 3/4 minus 7/8. I think I'm going to do that right over here. Get that common denominator. I see 8. Now this one already has 8, so 8 times 1, so that fraction is not going to change. It already has the denominator we're looking for. Here 4 times 2 is 8, so 3 times 2 is 6. Yes, we have to regroup. 6 minus 7, can't do it. There. I did that quickly so that way to save some time. It's all listed there. We're doing exactly the same process over and over again. What about 14c? Okay, our first one, I hope you got that one right. Does not require renaming. 16 minus 15 worked out. Okay, 14D. Okay, looks like we're going to rename on this one too. Okay, that completes the last one. So 14A was this one here. That required renaming. We also had 14B. That required renaming. We showed that. 14C, this one here actually did not require any renaming. And finally 14D is way down here and that required renaming. Okay, that's how we figured it out. All right, come on, let's move on. Oh, I think we need a page turner. Page master. Oh no. Oh, there they are. Gabriella and Claudia. Oh my goodness. I know, they look so sad. Let me see if I can use my trick I used the last time. Abracadabra. Woohoo! Yeah, yeah. You're free. You're free. Yeah. Cool. Now we just have to see if we can find Guillermo. Who knows where he is? Okay. But we'll work it out. Okay. Let's move on with our math problem. Yeah, yeah, yeah. Okay, since Mr. Clements painted his barn for 3 3/5 hours in the morning, he painted the barn for 5 3/4 hours in the afternoon. For numbers 15a and 15c, select true or false for each statement. Well, first thing, so we got something going on in the morning. We have something going on in the afternoon. It says a common denominator of the mixed numbers is 20. By just looking at the 4 as a denominator and the 5 as a denominator, and I'd have to multiply by fourths and fifths, lets me know that yes, that's true. Now that's also the least common denominator. Also, if 20 is a denominator, then so would 60. be a common denominator, but that is the least common denominator. Here it says the amount of time spent painting in the morning can be rewritten as 3 and 15/20 hours. Well, the morning hours were 3 and 3/5. And then they're saying that could be rewritten as, let's see if this is true, 3 and 15/20. Well, by looking at this numerator here, when I talk about equivalent fractions and I'm looking at that denominator, I can see I'd have to multiply 4 down here, and up here I'd have to multiply by 5. When I'm multiplying by, in this case, they're not fourths or fifths, but here I have 5 over 4. That kind of breaks the rule. So this is no, this is false. This is not an equivalent fraction. Now 15C says Mr. Clemens spent 2 and 3/20 hours longer painting in the afternoon than in the morning. The word longer should be like a red flag to let you know, okay, we're comparing. And when we're comparing something, we're usually looking for the difference, and the difference means subtraction. So I'm going to go ahead and take that amount from the afternoon in the morning. And the afternoon is longer than the morning. The question is by how much. So I'm going to take 5 and then 3/4. I'm going to subtract 3 and 3/5. So immediately I see a common denominator of 20. And I'm going to multiply by fifths here. That's going to give me 15/20. I'm going to multiply by fourths over here. That's going to give me 12/20. And I have 2 and 3/20. And yes, that's what I got. So I'm going to say, yes, that is true. Now it says Tom exercised 4/5 hour on Monday and 5/6 hour on Tuesday. Part A. Complete the calculations below to write equivalent fractions with a common denominator. So I have 4/5 is equal to 4/5 times. And in this case, by looking up at the problem, I can see a denominator of 5 and a denominator of 6. So I'm going to multiply by fifths and 6, right, in order to make that happen. It's a common denominator of 30, but I want to go ahead and make sure that that's clear. So since this is the 4/5, I'm going to multiply this fraction by sixths, okay? And now I end up with 24 over 30. When I come over here, I have 5/6 times. I'm going to multiply that by fifths, and now I have 25 over 30. Okay, pretty simple. Part B says, how much time did Tom spend exercising on Monday and Tuesday combined? And again, this should be a red flag for you when we see the word combined. We're adding, we're bringing two numbers together, putting them together, and so I'm going to add. So our two numbers were 24/30 plus 25/30. Now I end up with 49/30. Now you can see that this is a fraction that's greater than 1. So I'm going to go ahead and pull out one of those holes out of there, and that would be 30 over 30. I'm going to add that with what's left over, and I can see, just doing mental math, that's going to be 19 over 30. Now I have my one hole I can add on here and just show that as 1 and 19/30. Part C says, how much longer did Tom spend exercising on Tuesday than he spent on Monday? Okay, explain how you found your answer. Well, again, on this one here, if you look at it, I'm seeing a key word stand out. A couple of them. One is the word longer. We talked about that earlier, that longer, when we're doing a comparison between two people, two numbers, a quantity, you should think to yourself, oh, okay, we're trying to find the difference, and if we're finding the difference, then we're going to be subtracting. Now, it does also says that, then he spent on Monday is another way, part of that question where it's being compared. We have the same two fractions, very simple, because we had 25/30 and we had 24/30, so we were actually subtract those. That's extremely easy, right? Just 1/30. That's the difference. And explaining how you found your answer, I kind of already said that. We, to find the difference, we had to take the 1 and subtract. We already had the equivalent fraction, so that was already done for us. So we just subtract the numerators. And then remember the denominator, we keep it over. Remember, bring it over. That's all we do with the denominator. We don't make any change with that. Cool. Hey, is that you? Is that just me, or do I hear some jamming music in the background? It is time to close our video, my friends. This is editing. The end. But why is it that I still show whatever happened with our story with Guillermo? We're kind of bad about that. I mean, hopefully they'll kind of meet up with each other. Hey, there they are. They're already together. Woohoo! Yeehaw! Woohoo! Yeah. Oh, dude, don't even mention it. And that's what we do here in Mr. Warren Math Video Land here. We bring people together. We have happy endings. Now, my friends, live long and prosper.